everyone, astrophysicist here to talk about LIGO. The observatory is so powerful it could tell us how many grains of salt are between the Earth and Alpha Centauri. That's not an exaggeration. The Laser Interferometer Gravitational Wave Observatory is the most sensitive scientific equipment ever built, and its job is to listen to the universe. Black hole mergers, neutron star mergers, one-day supernovae, even the echoes of the Big Bang. But today I want to talk about the feat of engineering that LIGO actually is. This LIGO is in Washington, but there's another in Louisiana, one in Italy, one in Japan, and some are even planned for space. This LIGO has arms that are 2.5 miles long, at right angles to each other, and each one contains a laser 800 times more powerful than a laser pointer. Now, what the laser's there to do is to make waves, light waves. One goes down one tunnel, one goes down the other tunnel. Each tunnel has a mirror at the end that reflects the light back to the sensitive equipment at the middle. The easiest way to think about the physics at play here is to pretend that you're at the beach, and there's a boat passing, and that boat's going to leave a wake. Now, the regular ocean waves are going to interact with the wave from the boat. So you could have two big waves come together and make a bigger wave. You could have two troughs come together and make a bigger trough. Or you could have a big wave and a big trough come together and make flat water. The same thing happens at LIGO, except now the waves are light, and they're a micron apart. The equipment at the middle is measuring how the light waves combine after their trip down the tunnel and back. That produces this image. Unless a gravitational wave is passing through, then this thing goes nuts, and that's what they record as data. When something like a black hole merger happens in the local universe, it actually stretches our planet like a spring. We don't notice because it's only about the width of a proton that changes, but LIGO does. This method is called interferometry, and it's basically just the study of how waves interact with other waves. So if you do this with lasers, to study gravitational waves, all of a sudden you have a Laser Interferometer Gravitational Wave Observatory, a LIGO. Feel free to drop any questions in the comments, and I'll see you next time.